Hello, and this is Chase Alexander Stump narrating your current lesson. We will start with adding some subtracting f to x and g to x as the first example. First things first, you need to find f plus g and f minus g. This is pretty basic, similar to most algebra you've already done. You plug it in, and then you add and subtract. Pretty straightforward. So, f, f, yeah. You plug in f there, you plug in g there. Yeah, f there, g there, let's be blunt of it, and you're adding, order really doesn't matter. And you'll get this. What you gotta know is you gotta take, like numbers and put them together. That means that it's pretty straightforward. You're probably not gonna have much trouble with this. It's going to be the multiplying and dividing. If you have any trouble with anything, that is definitely going to be what you're gonna have trouble with. Next is subtraction. Now this is where order does matter. Same rule of thumb, x to x, number to number. Please note that if it's subtracting anything in the second one, it will become addition. This is easy to mess up on, and it can throw off your entire equation. Next, we're going to do multiplying and dividing. Now with this, it's going to be a little bit more tricky. This is the reason why the f of x instead of just using a or b. Really in the addition, adding, subtracting, I don't even know why they do it, but for multiplication, it tentatively f times x equals fg times x. So, plug them in as if you would normally. You first have to distribute the numbers. So, just for a basic example, 2x and x equals 3. Negative 1 and x equals negative 1. Negative 2x and 1 equals, x squared and 1 equals that. Then negative 1 and 1, well, you can tell me, can't you? Equals negative 1. Okay then. Just FOIL, like normal. Now, dividing is going to be a little bit of a different type of hassle. You have to take the square root of the top because it's a square, squared x. So since it's a negative, it's going to be one positive and one negative of the same number. Or the number that equals, generally the same. This avoids an x, or a stationary x being created in the process. You know this already though. So you're going to carry down the bottom, or the denominator, or whatever you want to call it. It goes by many names. You're going to want to cancel them, as shown below. When you cancel, you only take ones of like number. They have to be exactly the same, but you can cancel top to bottom regardless. Then you find x minus 1 will be eventually what you'll end up with. So when you want to state the restriction, you're going to do x does not equal negative 1. If the x doesn't equal 1, it's going to be x minus 1, so by that logic, x cannot equal negative 1 because on the denominator, the x minus 1 would evenly make it 0. If it were to make it 0, well, denominators cannot be 0. That's basically what a restriction is. It's whatever number the bottom cannot be. Really, this way to find a quite simplified answer, but still. This is your episode of mathematics. I hope you enjoyed your lesson. Also, remember, if in any case that you need to ask me or Ms. Johnson questions, you can reach us in our classroom. Literally during seminar. I've got our seminar.